I'm James H. Gilland. I'm a senior scientist at the Ohio Aerospace Institute, and the work I've been doing most recently has been in testing Hall thrusters, which is electric propulsion for a NASA mission to support Artemis. And over the span of my career, I've worked on electric propulsion anywhere from 300 watts to 300 megawatts. One of the unique parts of a plasma is that if you're interacting with electric and magnetic fields, you can start moving the charged particles around. And one of the things you can do, you can accelerate that plasma in one direction. Then you can accelerate it much faster than what we can do with a chemical rocket. Lunar Gateway is a part of the Artemis program, and it's going to be sort of a movable space station for a sustainable lunar exploration. And it's a fairly large object, and to use chemical thrusters would be much, much heavier, and you wouldn't be able to keep it moving as long as if you use these plasma thrusters that we're going to put on it. Traditional designs usually means DC, so direct current, which means you have a plus electrode and a minus electrode, and there's a current running between them. And those are metals that are exposed to this plasma that is kind of energetic. It's usually, to get a plasma, things have to be pretty hot. And when the plasma hits those metal pieces, it can erode them away, then your whole source goes away. The RF sources, they're nice because you don't have to touch them with a metal electrode. You don't have to run a lot of current through them. The chamber that they're in doesn't have to be a certain material for it to work. The RF is not contacting the plasma directly. The energy is going in essentially through the wall of your chamber, and that opens up what kinds of propellants you can use, and that already has increased the expected life of these thrusters by quite a bit. This is not a common area that you could study in undergraduate college. Not every university does it. For students interested in this field, my advice is make sure that in addition to the usual aerospace engineering courses, that you maybe take a little more physics to get the electricity and magnetism, to be a little more familiar with that than maybe the average student. And keep an eye out for the universities that are doing this work.